Hello everyone. Now in that sessions we are discuss Atmega 328P interfacing with LM35 sensor. Now before going to an interfacing, first we have to study what is LM35 sensor. Now here a circuit of LM35 sensor is shown. It consists of three terminals, VCC, output and ground. So that is a VCC. Supply voltage of that VCC terminal is between 4 volt to 30 volt DC. Then second is output terminal or also called as Vout. Its range is between 10 millivolt per degree centigrade. Then third one is ground terminal. So that is the terminal of LM35 sensor. Now its temperature range is 55 degrees centigrade to 155 degrees centigrade and sensitivity of 10 millivolt degree centigrade. That means uh, every degree rise in temperature, output voltage is increased by 10 millivolt. For example, suppose it gives a voltage 0 volt for 0 degree centigrade, then it gives a voltage 500 millivolt for 50 degree centigrade temperature. So that is the LM35 sensor. Now here interfacing diagram of LM35 sensor with Atmega 328 pin is shown. Here we are using a one Arduino board and that is LM35 sensor. So pin number 1, that is VCC, it is connected to 5 voltage of that Arduino board. Then second pin output is connected to analog pin of that Arduino board. Now here a 6 analog pin of that Arduino. Out of those we can select any one. Then third one is ground. So ground pin of that LM35, it is connected to ground pin of that Arduino. So that is the interfacing diagram. Now here interfacing with an LCD display is shown. Now the here we are using a 16 by 2 LCD display which are connected to IO ports, that means input output terminals of that Arduino board, and three pins. Likewise first pin is connected to that VCC, then second is connected to output and third is connected to ground. Such a connections are shown in that figure. So that is the interfacing. Now next one is algorithm. So out for that algorithm, first step is start. Then second one is include liquid crystal.h library file. Then third one is configure Arduino A1 pin as an analog input to read a LM35 sensor output. Then fourth step, declare a variable for storing temperature value. Then fifth step, read LM35 sensor value and convert it into a degree centigrade. Then sixth one, display a value on LCD, and last one, end the program. So that is the algorithm. Now here a program is shown. So here we are using a library code, that is hash include liquid crystal.h, and for that LCD display we are using a 6 pin. That's why we can write liquid crystal 8 9 10 11 12 13 for set interfacing pin of that LCD with an Arduino board. Then next one is float temp C. It can be used to variable store in degree Celsius. Then float Vout, that is temporary variable to hold a sensor reading. Then in an file setup, here we are using a one pin mode A1 comma input. That means we are using a A1 pin as an input, or configure a pin A1 as an input. Then here we are using a 16 by 2 LCD display. For initialize that LCD display, we can write LCD begin 16 comma 2. Now here we are set a baud rate of 9600. That's why we can write serial dot begin 9600. Then in an while loop, so Vout is equal to analog read A1, that means read analog value from pin A1. Then Vout is equal to Vout into 500 divided by 1000, that means Celsius value from 10-bit analog value. It indicates a Celsius value. Then next one is temp C, it is equal to Vout, that means you have to store the value in degree centigrade. Then LCD cursor 0 comma 0, here we are using a 0 cursor and 0 column of that LCD display. Then LCD print in degree centigrade, LCD print temp C, and here we are using a delay of 1000 millisecond or 1 second. That means 1000 millisecond is equal to 1 second. That's why we can write delay 1000. Okay, thank you.